What's up guys, welcome back to the channel. Today on this video we will be deriving the following polynomial. So as you can see here, this is the function that we have. Now if you are returning to this channel, you can pause this video and try to solve this problem, and let's see if we can manage to get the answer as the one that I'm going to get at the end of this video. Now if you are new to this channel, I would say subscribe to the channel, because I made lots and lot of videos on this subject, which is maths, and also I'm still gonna make lots and lots of videos on other part of maths and previous question papers, so that you can use them to practice. So guys, if you want to watch videos on trigonometry, you want to watch videos on expansion, limits, binomial theorem, you can go to the playlist section. I've made videos there. Go and watch those videos there, and yeah, you will see what is it that you need to watch there. But let's start with our problem here. Before guys you start with this problem, remember you need to first simplify this in a way that it's in a form where we can differentiate. So as you can see, you also need to identify the term. So the first term here is a trigonometric function. The second term is actually logarithmic function. The third term, as you can see here, it's actually the standard function, so it's going to be a standard derivative. And the last term, as you can see, x is our exponent, so it's going to be exponent function. So you need to know these derivatives, guys, otherwise this is going to be hard on you. Now let's simplify this. Remember, we cannot differentiate when x is on the denominator, and we also have sat the root. We cannot differentiate. We need to get rid of this problem here. We need to fix this one, in fact. So unfortunately, do not differentiate anything before you fix everything here. All right, let's continue. I'll try to be quick. So the first term is fine. We can just leave it like that. 2 tan x plus, and then we have log base 5x over 4, and then minus. Now this one we need to change, so we have 2 multiplied by x. If we write the square root in terms of exponent, it's root 1 over 2. Okay, it's a exponent 1 over 2, and then this one here is still fine. We just have to rewrite it as it is, guys. I'm gonna try to be quick so that we don't waste time. This is gonna take a bit longer, so let me try to be quick. So we continue. I know this can take long, but it's very important, guys, for us to do this. Okay, all right. The second step, we continue with this one. This one, guys, it's like that, so we don't mess with it. Okay, x. All right, so we say minus. Now we have the following here. We know that the base, if the base are the same, what happened to exponent? The answer is going to be 2 plus half. 2 plus half. All right, so this is going to be plus exponent 6 over log natural log 6. All right, do this one here, which is going to be the last step of our problem here. Base 5, then x over 4, and then minus. Look, what is as you can see, what is 2 plus half? So this is gonna give us 3. It's gonna give us 5 over 2. Now if we take this x to the numerator, we're gonna have x to the power of 5 over 2. All right, but let's not forget, it's on the numerator, it's gonna be negative. I almost forgot about the negative. You see, trying to skip the steps here, it can be sometimes challenging. Okay, negative me just write it here, negative 5 over 2, that is our exponent, plus, and then 6 to the power of x, and then natural log, then 6. Okay, now when it's like this, now we can able to solve this problem here, guys. When it's like this, we can able to solve this problem. Just open space page here. We can able to differentiate this. Now let's start with the first term here. We know that the first term is our trigonometric function. Now when we write the derivative of this trigonometric function, so this is going to be like this. It's going to be y is equal to, we do have k there on our first term, and then tan, and then we do not have the x coefficient, so we're just going to write x, and then dy over dx. We know this is going to be sec, it's going to be k sec square. It's going to be k sec square x. All right, let's not forget that. So when you look at this here, the first term, our k is going to be negative 2. Or let's just make it 2. Let's just make it 2. It's going to be 2. Right. Now, I tell people, if you don't understand this formula where it's coming from, go and watch this video here that appears here, that pops up here. And then I explain these formulas here. In fact, I show you guys these formulas, how do they work. Okay, all right, now let's substitute this formula here on our first one. So we already have the negative here, and then we know that k is gonna be 2, so we can just say multiplied by 2, negative multiplied by 2, and then what is the following one? It's gonna be sec squared. All right, so let's write our sec squared, sec squared x, and that's it. This was very simple, straightforward. Now let's look at our second term. Now our second term, we have log base 5x. All right, so when we look at our formula, our general formula for log, we do have k here, so it's going to be k, and then we have log, okay, and the base is going to be a, and that is x. And then when we find dy over dx for this one here, guys, it's going to be, well, let's write it. It's going to be k, all right, multiplied by, what do we have here? We have 1 over x natural log, then a. All right, so stop on this one. Do not continue and change this natural log into log. Okay, stop here. I think it's better for us to stop here. So when you look at our second term here, let's start with k. Our k here, it's actually 1 over 4. Remember, this is divided by 4, so it seems we can say there is 1 here, and then divide by this 4 here. Do you guys see? So basically that's what is happening there. Okay, now we have our a. What is our a in this case? The base. So the base here is 5, and then what is our that's it. It's a base, and we do not have, fortunately enough, we do not have n, so we are all good. So if we substitute this one here, this side, we're gonna use this k here and this a here. Now let's continue. Now do not forget, this is what we substitute then. Okay, so we have plus, so this is going to be plus, and then what is our k? Our k is 1 over 4, and then multiply by our derivative of this log. So we know that log is 1 over, and then we have x, and then we have natural log, and then a. What is our a? It's 5 in this case, and this is how you derive this one. Now let's look at the third term. All right, guys, if it so happen, before we go to the third term, look, I've made a video explaining this as well, guys. Then go and watch those video or that video explaining this formula that we use to derive the log. All right, guys, let's continue. Now let's look at our third term. Now our third term is the standard function or standard derivative. Now if you still remember, done this, we have made a video on this one. I'm going to show you the video. We have x. Now we do not have k, the coefficient of x. We have y, so we do not have the coefficient of x there, so this is just going to be x to the power of n. And then when you find dy over dx, our answer it's gonna be, let me just write it very quickly. You know that the formula is very simple here, guys. The formula is just it's n multiplied by x to the power of n minus 1. This one is the standard derivative, guys. I hope you still remember. And then you just have to look at n. What is our n? Our n here is negative 5 over 2. All right, so that is our n. So what we need to do here is to substitute this formula there when we do our derivative. So let's do it, guys. Let's do it. Okay, let's not forget we have a subtraction here, right? And then we multiply by n. But what is n? It's negative 5 over 2. So negative 5 over 2 multiplied by x. What is x? Well, x is x. And then we have n, which is negative 5 over 2. I hope you can see minus 1. Remember, minus 1 here. Okay, and then if you don't remember, guys, I made a video explaining this formula that we used there to derive on this video that is going to pop up there. So guys, go and watch that video if it's so happen that you didn't watch those videos, or if you don't understand what's happening here. All right, let's go to the other one, the last term. As you can see, the last term we have what we have here is this one here. Okay, we have the exponent x here, okay, but it's divided by natural log 6. So if you look at the formula, obviously the general formula is y is equal to 2. Now in this case we do have k, it's going to be k, and then we have a, and then unfortunately or fortunately we do not have the coefficient of x, so we do not have n, so this is just going to be x. So when we find dy over dx of this problem here, it's going to be k multiplied by ax, and then multiplied by natural log then a. Now we need to know what a is, what x is. So what is k. So when you look at our formula there, let's start with k. Okay, let me just go here and show you guys what is k. Look, this here is divided by this here. This thing here is actually divided by 1. It's 1 divided by natural log 6. This is a number, guys. This is a number. So this natural log here, it's actually dividing everything here. So this is a number, so we can treat it as k. So we can say our k is 1 divided by natural log 6. Okay, and then what about our a? What is our a? Our a is actually 6, the base. So 6 is the base. This base here, guys. Okay, this is the base. This is the base. Okay, that is 6. Hope you can able to see that. Okay, let me close this. Now let's do this problem. Wait, before we do it, guys, this formula here comes from this video here. Go and watch this video, and then I kinda explain how this formula we use it, or how to apply it. Okay, right, so we have plus here. Now let's do this. Now if you look at k, what is our k? K is 1 over natural log, then 6, and then multiply by what is our a is 6 to the power of x, remember, and then natural log here, and then a, which is this one here. All right, so this is the derivative of this polynomial here. But what you should know now, we need to simplify it so that we can have the right answer. Don't leave it like this, guys. Simplify it, subtract, divide if you have to divide, add if you have to add. Now the first term, we are fine. It's supposed to give us like this. Actually, it's like this. It's fine like this. There's nothing we can do here. And then our second term, it's also fine. We just multiply here. We can say 1 over 4x, and then natural log 5. Leave it like that. Then our third term, we do have x multiplied by we do have negative multiplied by negative, makes this one to be positive. So we're gonna have positive 5, and then let's say over 2, because we have 2 here. But what is negative 5 over 2 minus 1? So we're gonna have x to the power of negative 7 over 2. There we go, 7 over 2. And then let's look at the last term here. Look, we have natural log 6 and natural log 6. So this natural log 6 and that natural log 6, they're going to divide each other. You're going to be left with 1 multiplied by 6 to the power of x. So this is going to be 6 to the power of x. Right. Now, remember, whenever we solve this problem, never ever leave your answer with positive exponent, with negative exponent, I need to say negative exponent. And also, if it's a fraction exponent, we need to leave it in a sad form. So we have to first change this into a positive exponent. Okay, let me just be quick about it. These ones are fine, so that's why I'm just rewriting them as they are, guys. Okay, writing them as they are. So if we change this to positive exponent, we know that the base of x is going to be on the denominator, and then the exponents here is going to be positive. All right, and then plus 6. Okay, so this is not the final answer. The final answer should be dy, because we do have a fraction here as an exponent, so it should be negative 2 sec squared x plus 1 over 4x natural log 5, and then plus 5. Now this is where you're supposed to change this into sad form. We have 2 here, and then we know that this is squared, so it's gonna be this is 2 is gonna be a root, and then it's gonna be x to the power of 7. Oh, I hope we can be able to see this. Let me just open more space here. X to the power of 7. All right, and then we say plus 6 to the power of x. So this, guys, is our final answer. I hope you guys managed to understand what is happening here. It was a bit long, but I don't think it was challenging. As long as you know how to simplify and you know the different types of integration, then we are fine for each and every function here. So guys, if it so happened that this video helped you to understand or help you to able to solve, then don't forget to like and subscribe the video. You can also comment. If you are new on this channel, what are you waiting for? Subscribe to the channel, guys, because I'm gonna make more videos. I'm gonna do previous question papers. So you can also click the bell icon so that whenever I upload a video, you are able to see that video first. And then at the end of this video, there will be a playlist. Go and watch that playlist where I solve the about 5 polynomials problem. So this is the 6th one. So if you want to watch other problems like this, they will appear at the end of this video as a playlist. Thank you very much, guys, for watching. Do not forget to subscribe. Till next time, cheers.